Today we are going to learn about advanced tips for grid search with cross-validation, focusing on optimizing model parameters using grid search with cross-validation in Scikit-learn. You'll acquire skills for efficient parameter tuning to enhance model performance.
Welcome to our detailed exploration of grid search and cross-validation. These are powerful methodologies used to optimize the performance of machine learning models. Grid search allows us to systematically work through multiple combinations of parameter tunes, cross-validating as it goes to determine which tune gives the best performance. Cross-validation, on the other hand, is a technique to assess how the results of a statistical analysis will generalize to an independent dataset. By combining these two techniques, we can improve the robustness and accuracy of our model predictions. Scikit-learn, a popular machine learning library in Python, provides a simple and efficient tool for data mining and data analysis, making it a preferred choice for implementing these techniques. In this video, we'll dive into advanced strategies to fine-tune models using grid search effectively.
Setting up a parameter grid is crucial in the grid search process. A parameter grid is essentially a dictionary where we define the parameters we want to test and the range of values for each parameter. Choosing the right parameters to tune is a critical step. These parameters could be hyperparameters of your model, such as the number of trees in a random forest or the penalty parameter in a support vector machine. Defining the range or list of values for these parameters is equally important, as it determines the search space of our grid search. For instance, if you're working with a random forest model, you might define a parameter grid that includes the number of estimators, maximum depth, and minimum sample split. In Scikit-learn, this can be set up using the param_grid parameter in the grid search class. By carefully setting up a parameter grid, you can ensure that your grid search explores the most promising areas of the parameter space, increasing the likelihood of finding an optimal set of parameters.
Integrating grid search with k-fold cross-validation is a strategic approach to enhance model performance. K-fold cross-validation involves splitting the dataset into k smaller sets, or folds. The model is trained on k1 of these folds and tested on the remaining one fold. This process is repeated k times, with each fold serving as the test set once. The results are averaged to produce a single estimation. By combining this with grid search, we ensure that our hyperparameter tuning is robust and not biased by any particular subset of data. In Scikit-learn, this integration is straightforward using the grid search class, where you can specify the number of folds using the CD parameter. This setup helps in avoiding overfitting by ensuring that the model's performance is consistent across different subsets of data, thereby improving its generalization to unseen data. This approach provides a more reliable estimate of the model's performance and helps in selecting the best hyperparameters for your model. Balancing computational cost with model precision is one of the challenges faced when performing grid search with cross-validation. The search for optimal hyperparameters can be computationally expensive, especially when dealing with large datasets or complex models. Therefore, it's important to consider the trade-offs between the computational cost and the precision of the model. One strategy to manage this is by initially reducing the search space. Instead of testing all possible combinations, focus on those most likely to yield improvements. Another approach is to use random search for an initial rough tuning, which can help identify promising areas of the parameter space to explore in more detail with grid search. Additionally, setting a computational budget, such as limiting the number of parameter combinations or iterations, can help manage resources effectively. Optimizing resource allocation, such as using a more powerful machine or parallel processing, can also alleviate computational demands. By carefully balancing these factors, you can optimize model performance without excessively draining computational resources. Handling large datasets efficiently during grid search with cross-validation is essential for maintaining performance and speed. Large datasets pose challenges such as increased computation time and memory consumption. To address these, several strategies can be employed. One approach is to use mini-batches, processing small subsets of the dataset at a time, which reduces memory load and speeds up computation. Data sampling strategies, such as downsampling or using representative subsets, can also be effective, allowing for quicker iterations. Incremental learning techniques, which update the model with incoming data rather than retraining from scratch, can be useful when dealing with streaming data or when memory constraints are tight. Additionally, leveraging data reduction methods, such as feature selection or dimensionality reduction techniques like PCA, can help in simplifying the dataset while retaining necessary information. By implementing these strategies, you can efficiently handle large datasets and ensure that grid search remains a viable tool for hyperparameter optimization.
Using parallel processing is a highly effective way to speed up grid search operations, especially when working with large datasets or complex models. Parallel processing allows multiple computations to be carried out simultaneously, significantly reducing the time required to complete the grid search. In Scikit-learn, this can be easily configured using the n_jobs parameter in the grid search class. Setting n_jobs to -1 will utilize all available cores on your machine, maximizing computational efficiency. This approach is particularly beneficial when handling computational bottlenecks, which can occur when processing large amounts of data or complex models. By spreading the workload across multiple cores, parallel processing ensures that resources are used optimally, speeding up the overall process. In practice, this can result in a substantial reduction in the time required for grid search, making it a viable option even for time-sensitive projects. By leveraging parallel processing, you can achieve faster results without compromising on the thoroughness of your parameter search.
Interpreting the results of a grid search is a crucial step in the model optimization process. Once the grid search is complete, it produces a wealth of information about the performance of different parameter combinations. Understanding these output metrics is key to evaluating the success of your model. The main goal is to identify the set of parameters that results in the best model performance. This involves analyzing the cross-validated scores for each parameter combination, which provide an estimate of how the model will perform on unseen data. Additionally, visualizing these results can offer valuable insights, making it easier to spot trends or patterns that indicate which parameters are most effective. Tools like heat maps or line plots can be particularly useful in this regard, offering a clear graphical representation of the results. By thoroughly interpreting the grid search results, you can make informed decisions about which parameters to adopt, ultimately leading to a more accurate and reliable model.
Implementing a grid search pipeline is a best practice for streamlining the model tuning process. Pipelines in Scikit-learn are a powerful tool that allow you to chain together transformers and estimators, simplifying the workflow and reducing the risk of error. By using a pipeline, you can combine preprocessing steps with the model training and hyperparameter tuning, ensuring that all operations are applied consistently across each fold of the cross-validation. This is particularly beneficial when working with complex data transformations, as it maintains the integrity of the data preprocessing steps throughout the grid search. Setting up a pipeline with grid search involves defining the sequence of steps, including any data preprocessing methods and the model itself, followed by specifying the parameter grid for tuning. An example of a complete pipeline might include steps for scaling the data, applying PCA for dimensionality reduction, and training a random forest model, all while tuning the relevant hyperparameters. By implementing a grid search pipeline, you can enhance the efficiency and reliability of your model tuning process.
As we conclude our exploration of advanced tips for grid search with cross-validation, it's important to recap the key strategies discussed. Efficient parameter tuning is vital for improving model performance, and grid search combined with cross-validation offers a robust approach to achieve this. Balancing computational cost with model precision, handling large datasets efficiently, and leveraging parallel processing are essential considerations for optimizing performance. Implementing a grid search pipeline can further streamline the process, ensuring a consistent and efficient workflow. It's important to continuously learn and adapt, as machine learning is a rapidly evolving field. By leveraging the features of Scikit-learn and following best practices, you can enhance your model tuning process, ultimately leading to more accurate and reliable models. Thank you for joining us in this exploration, and we hope you found these tips valuable in your machine learning journey.